This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and it's a pleasure to talk to
Peter Seberg, just returning from fitness. Good morning, Robert. Good morning, afternoon, evening to all of you, dear listeners.
Peter. Let's start with the news. What do you have?
I have only one topic.
Me too.
Yeah, one topic, two cooperations, two industry,
Okay.
let's say IT/industry cooperations. The first one is between Honeywell and Google Cloud. And maybe this topic is bigger than what as such, maybe there is something on the higher level actually. So let's look into that.
Yep.
Honeywell, Google. So that's about two companies, Google Gemini, large language model. Sure. Bringing together two platforms. So on one hand, it is the Google, it's called the Vertex AI platform. Some of you may know, maybe you know, Robert.
Never heard.
On the other hand, it's the Honeywell Forge IoT industrial platform. And let's say higher level, maybe their meta, as I like to say, topic is the path to autonomy, right? Or let's keep that in mind when we look at the second one a bit later. Now, I've marked this podcast as you and I, we chat typically after our every weekly, bi-weekly chatting that we look into what are we going to be doing. And already the first 3 months of the next year, we haven't looked into yet so many topics. And we, of course, need to always make sure that we're going to be very, very current, that we look at actual topics. But you make...
But Honeywell is big in the USA, right?
Most certainly,
Yep.
certainly. Honeywell is huge. So that's why, I marked it as a podcast topic for the beginning of the new year. So anyone from Honeywell listening, please, make yourself known, contact us, and very much forward to doing that with you. Now, that's the number one.
But this is interesting because they rely on Google, on Gemini, yeah?
Exactly.
The other industries are all relying on Microsoft, right? Yeah.
That's exactly the topic, right? Now, let's combine that with the second one. That's about an existing corporation. Satya visited Berlin. When they say Satya, everybody knows the family name, which is? Yeah, you're close. Nadella. I think it is correct like that, right? Satya, is that how you pronounce it? So Satya visited Berlin, Microsoft, and talked about how he saw Siemens Industrial Copilot helping ThyssenKrupp addressing the growing skill labor gap in manufacturing and drive new growth. So that's a very similar story right now. What's very interesting is that, we keep coming back to SAP's famous 6 years back quote of a person talking to a machine, right? And a machine talking back, telling the person in front, my oil level is okay and I'm doing fine. Remember? So the story goes like this. Chemnitz, Germany, a small corner of a vast ThyssenKrupp factory in the industrial town, an engineer talking to a machine. There you go. So from the beginning, I was only speaking to it in English, but today I discovered it speaks German quite well. Says Markus Schönherr, one of the ThyssenKrupp engineers using the Siemens Industrial Copilot to program and test the machine. I'm not going to go further. If you have been listening to Robert and me talking about large language models and how they are being used as a, human-machine interface, then you can very well imagine. We're going to put a link there. It is actually a very interesting story, I must say. I also put the YouTube video out, and some people who saw it may say, well, nothing new, but nevertheless, look at it and you can see what people are actually doing with the large language models in an industrial environment.
And we had an episode on the Industrial Copilot by Rainer Brehm. Yeah.
Exactly. And we'll come back to that in a moment as well, actually, because that was a very important message about monetization, making money. Let's call it just making money with new technology. And let's hold that thought as well. Now, in this case, the higher level, the meta topic is using the power of AI to compensate for a shortage of skilled workers in manufacturing in Germany, in Europe, many other countries. That's a quote actually from Microsoft, including the United States. That's the other thing that we talked about a lot as well. Now, and I would say that is not too far off from the Honeywell Google path to autonomy. I would say one is the challenge, the problem we have at the very, very moment. And this issue of not having professional people available is only getting bigger and bigger. And the other one, I would say the path to autonomy is, the potential solution. I always keep on saying, very important, no reason to go for autonomy where we have, loads of humans available that are very eager to make money. Yeah, let's use that word again. It's the very same thing. People need to have a reason for, living, so to say, although now that becomes very philosophical. Now, by the way, I did ask Satya on LinkedIn. I hadn't seen him on LinkedIn. That's another interesting thought, because that's his communication channel, right?
Yep.
Somebody else in this world who owns X, Satya in a different way. You could almost say he owns LinkedIn, right?
Yeah.
In a different way, but nevertheless.
Yeah.
So I asked Satya if he would be interested in doing a podcast on a topic. He hasn't reacted so far, but
oh, what a pity.
Well, there you go. But nevertheless, at the same time, and I really believe completely independent from each other, we had Sam Murley, and Sam is from Microsoft. He's based in, not sure I pronounced that correctly, Dubuque. That's in Iowa, Dubuque in Iowa. And he advises companies on industrial AI. He contacted me, so we'll do a podcast beginning of the year. Sam, I will ask you, so you can prepare. You have 2 or 3 months, because your top line quote is, and there we go, how to turn new ideas into revenue. To put it differently, how to make money with industrial AI.
Peter, you are a robotics fan, and
yeah. Sure.
Yeah, sure. And last week was ROSCON in Odense in Denmark.
In Odense, I've been there. Okay, I'll tell you about it. Yeah, tell me.
ROS is an open source framework for robotics.
Right.
And do you know which companies put on the big show there, Peter?
No.
It was NVIDIA.
Oh, because is that the answer to the question you put on LinkedIn?
No.
No, that's a different story. NVIDIA was there. Oh, wow.
And they are discovering the ROS market for themselves.
Uh-huh.
And they presented various ROS adaptations, and the experts in robotics celebrated NVIDIA. And from my point of view, many of them didn't even notice that the Americans were taking market shares away from them, from the traditional robotics manufacturers.
Okay, I was going to say, where from? Let's say from the hardware, so from the people building the hardware, or from the people building the software around it?
Both worlds, because the robotics companies, the manufacturers are also building software, right? Simulation and software, etc., etc.
Yeah, my question is going to be exactly that. And I think we had the discussion a couple of times. It's about, if I go very far back, it's like, the way that at least in my generation, that I was raised when I made pictures. And if you have 10,000 pictures somewhere on the drive, you had to, and I did that story before, you have to say, this is my son, and this is Rome, this is Italy, there's my wife, whatever. So that when I want to go back, I need to put in 2 or 3 search words and I find them back. Now, I typically see, and let's talk about again, in this case, it's a coincidence, Google and Microsoft. If I do that on the Microsoft Explorer, that's the only way I can do it, I believe. If somebody else knows that is not correct, let me know. If I do it on my Google Drive, then Google today, as an example, really just an example, will find, even if I had not said, this is a picture of Rome, it will give me pictures of Rome because it knows. How does it know? Because of large language technology, et cetera, et cetera, et cetera. Now, the point is, my question to you is so the people who have been building ROS as open source for, I assume, 10, 20 years, I have no idea. And now NVIDIA or anybody else comes in with large language models. So with algorithms in combination with models that know the foundation of the world, or if they have been trained very specifically in an industrial environment, I'm going to tell them, hey, robot, you see that cup of tea here on the table, take it. and bring it to the kitchen for me.
That's the vision, yeah.
And my question to you is that then still using ROS, or is it using, foundation technology of a robot being a piece of software, understanding what it means that there's a table and there's a cup of tea, etc.?
That's a huge discussion in the robotics market in the moment.
I can imagine.
And every week I receive messages where another university is developing a foundation model, a world model for robotics. So everybody is focusing on this world models, foundation models for robotics. And there was even more at the ROSCON, and that was really surprising for me. There was even a cobot, this collaborative robots,
Sure.
with a GPU. And I'm very excited about this use case because somehow it doesn't add up for me.
It does not add up.
Yeah,
to you.
because in the end, the Chinese will laugh because for most applications, they simply supply standard cobots at a low price. And we are now producing cobots with a GPU. And I'm not convinced by this approach to build now cobots with GPUs, and the whole standard market, the whole standard application will be provided by cheaper suppliers from China. I think that's not a good message.
When you say GPU, you mean a whatever, I don't know in detail. Is that a 50,000 euro NVIDIA?
I'm not sure what is it, but
Right.
you have to add this gray box next to your robot, right?
Oh, is it next to? Yeah. Yeah, okay. But then it's going to take a couple of years, and it's going to be a chip the size of your tiny pinky, right? And it's going to be somewhere inside, and nobody's going to see it.
We need to talk about edge AI in the robotics market, yeah.
So I hear what you say for today, but maybe in 5 years, most certainly, are any kind of, is this word ubiquity, which we had in the 90s at Intel. IT technology is going to be all everywhere around you. And that's most certainly still going to be the same. We have it, we have everything around us. We have our lives goes on, and there's still so many things to do. Same thing for the robots, for these pieces of hardware that will be walking around or will be moving. Maybe they will not be walking because, as you know, I do not always believe in the humanoid version, but nevertheless, I hear what you say. So there's one version you say, which is, let's say, the 10,000 euro, or maybe even less, the 1,000 euro version. And you say what they were showing is then maybe the 100,000 or the 50,000, as we have had, for 30 years, typical global industrial robots, right?
And there's an interesting research project going on in Amsterdam. It's from Stratis Gaffes, and he works together with a lot of European companies, Switzerland, on edge AI, neuromorphic chips as a solution, not to put a GPU or anything else next to a robot. So there's something coming, and there's research going on. Yeah.
Okay. Yeah, but that is along the same lines, I would say, right? Without knowing the details. I mean, it doesn't matter how you call the thing, call it, and I mean it in a positive sense, call it neuromorphic, call it whatever, call it a GPU, call it a CPU, doesn't matter, a central processing unit, graphical processing unit, call it NPU, neuromorphic processing unit, doesn't matter. It's a piece of silicon, which until we move to a new technology, and you're in charge of that one, me not, we have lines of in silicon etched, and they're coming a couple of atoms apart from each other. And what you call and what you design with it at a higher level, of course, there's always advantages, disadvantages. And the one time you need to put a box next to a machine, and 5 years later, it's very small piece, you don't see it, it's included. So the question still is, how do what you call the Chinese robots, are they clever then or not?
But I think we don't need that.
Why not?
For the most cobot use cases, we do not need GPUs next to the cobot.
All right, sure.
So it's not a AI cobot.
They do stupid things.
Yeah, exactly. Blue collar AI. Focus on blue collar AI.
Sure, but I'm sure that other people will tell you, or I don't. That is most certainly one way of doing things, and maybe it's the 99% one. I have no idea, but there's most certainly use cases and potential for putting a lot of knowledge inside of these robots,
Sure.
And then they do a higher level of work.
But the idea of cobot was very cheap and easy to integrate and plug and play, and that's the idea of cobots.
Right. But haven't we seen, when was the first production line, the T Ford typically? Is that 100 years ago?
Yeah.
Right. And that was, build one car and you could buy whatever color you wanted as long as it was black. So
Yeah.
it even had to, so there was no, well, there was a painting, a painting facility, I guess, but the only color they were handling was black. Now, but my point is, so that has been there for until 10, 20 years ago or longer. I'm not a professional on that one. And then we've seen many different ways of production with cells and separate and parallel. And there's so many people out there who know so many things about it. But I can at least imagine that the approach you talked about, that is the one, you say the cobot, and it's very cheap, but there must be another potential, at least, for very smart and clever. I mean, even the ones that you've been showing, or the Chinese, the one from the Tesla guy, they are these humanoid versions, which are, and I don't believe in the humanoid version of it, but nevertheless, they're supposed to be smart, intelligent robots. So at least there's people believing in that there could be a potential market for that as well.
I'm not convinced because there are a lot of topics when it comes to cobots, payload,
Right.
for example. But yeah, maybe I'm wrong. And if somebody is listening to this episode and say, Robert, you are totally wrong, write me a message, convince me.
Oh, you're not totally wrong, but
Yeah.
let's see where the future is going to be.
Then I have some informations about our last episode. It's about our events because there was some confusion. So if you have never been to our events, you have to apply. If you have been before, you can register directly for the next meetings. Peter, what else do you have?
Right. And that is because when we started it 4 years ago in Würzburg, I think, because it was born out of a group of people who initiated this together with us, right? And they said, we want to meet on a regular basis. And that's why it is we want to make sure that the group still fits in a nice way together. I don't have any other news activities this week.
Let's move to the main part.
Let's talk a little bit about it because it's very, very interesting.
This AI-defined machine, yeah, maybe that's the future, because I did an interview with Jacek from ASML, and he's waiting in the main part. And you heard the episode. What is your opinion?
Yeah, it's very impressive. Number one, most impressive is that he is so open about what it is they're doing. I think we are now talking just 2-3 days before you, dear listener, if you listen this in the first day, maybe later, we are now aware, end of October. And it was only a couple of days back where I believe the CEO of ASML, he did a talk, not sure where it was, but it's all about politics, and ASML is so central, so exclusive central in global chip manufacturing. And I think number one, he was talking about, and I did not listen to his talk. That's another thing we maybe or maybe you did actually before you did your podcast. And he talked about, AI for chip manufacturing, which of course you did as well. But he also talked about how he assumed that the United States was going to make exporting chip manufacturing capabilities into China even more difficult. I'm not going to give my perspective on that. I don't want to be, I believe we don't want to be political. We like it. If you are from China listening, if you are from the United States, we're not going to make any political statements. And he needs to say that because he's a CEO. And the people who invest in his company need to know what he believes where the market is going. And then actually he was giving that a view on, how his perspective of the year, and then the stock came down very quickly. So what am I saying here? If you would have been talking to a person in a similar position of any of these companies who received the equipment from ASML, they would maybe not have been so open and honest about the things that you were talking about. That is very amazing. And that's why I would strongly suggest you, the listener, listen to this specific podcast that Robert did.
Let's do it, Peter. Thank you very much. It was a pleasure.
Very good. Looking forward to. And we'll talk again soon and hope to have you back, dear listener, with us again very soon. Bye-bye.
Bye-bye. My guest today is Jacek Kustra from ASML. Jacek, it's a pleasure to have you here.
Pleasure to be here, Robert.
Before we start, please introduce yourself briefly to our listeners. Who are you and what do you do at ASML?
Yes, so Jacek Kustra. So I'm a group leader in ASML research, leading the Diagnostics and data science group. So I have been in this position for the last 3 years. Before that, I was in the development engineering part of ASML, leading the algorithms and image processing group. Before that, over a decade in Philips, also various positions there. In terms of academic background, studied electronics and telecommunications, followed a passion for biomedical engineering, and then a PhD in computational geometry.
Are you an engineer, right?
Correct. Yes. In my heart, I will remain an engineer, although right now I'm a so-called manager in ASML.
But not an IT guy, right?
No.
Oh, okay. Before we talk about ASML and AI, think back over the last 3 months. What AI development or approach or news has impressed you?
So I think in the last month, what has struck me was John Hopfield's Nobel Prize, bringing together physics and AI, as that is also in the heart of
an engineer.
Yes, indeed. But it's and maybe that then also propagates further because that is also in the heart of the ASML developments and the research we're doing here.
Okay, it was a big surprise for the whole community, I think, physics and AI. And maybe because you mentioned Hopfield, I have a reading tip for you. It's called Hopfield is All You Need. It's a paper by Sepp Hochreiter, Günter Klammbauer from JKU Linz. They invented modern Hopfield networks. And that's quite interesting. Jacek, you should read that paper too, right?
We'll definitely put it on my reading list, yes.
Let's talk about ASML. In which fields of AI do you see the most potential for ASML and why?
So we typically think of AI in ASML in 3 different categories. One is the AI that helps us work more efficiently, such as you could think of Copilot, for example, for faster coding, code reviews, for example. The other category is the AI that enhances our products. And then the third category that is also very important in ASML is the AI that is used to service our products and perform diagnostics.
So do you separate between, let's say, Gen AI and good old-fashioned AI there?
To some extent, yes. If I think of how we categorize the different research projects, that we divide into 4 categories. Like one is what we call knowledge-informed learning. And this indeed brings us back to the first question, where we bring together physics and data information. The second category is the next generation algorithms, as we have problems with we require high throughput, for example, different types of inverse problems that we need to work on. And the third category, that is where a lot of the Gen AI comes into play, is the category of knowledge and reasoning. Very much applied to our diagnostics problems, but not only, also for developing new products. There, Gen AI plays a big role. And then the final one is on the human-computer interaction. So keeping also the human in the loop and ensuring that we have the right information at all times to make decisions, and making sure that we not only use artificial intelligence, but also human intelligence, if we can call it so. So I wouldn't say the distinction is very clear that Gen AI only applies to one of those categories, but it mostly applies to the knowledge and reasoning part.
You mentioned next generation of algorithm. What does it mean?
Well, in the next generation algorithms category, that's a little bit of an umbrella category where high complex inverse problems, like in our computational lithography domain that we need to apply, but also the very high throughput type of problems. Because in that domain, it's not only about the latest and greatest AI algorithm that we're looking into applying, because the higher the throughput, for example, in the case of metrology, if we increase the throughput, we have less acquisition time. Typically, that translates into a lower image quality. And then if we need to analyze that image, on one hand, we need more complex algorithms, but since we're increasing the throughput, also our computational time is restricted. Therefore, we need to simplify the algorithms. And that is like the thin balance that we need to act upon. And just to give you like the scale of the problems that we're dealing with when like inspecting in our metrology and inspection problems, we're typically looking for defects where the order of magnitude is like finding a penny in the area of Europe.
When I talk to machine building companies, and you are also a machine building company, maybe not a traditional machine building company, I always hear that the deployment of AI models is the most complicated part in the whole project. So POC is built very quick and everybody says, yeah, I like that, let's do it. But the deployment is the most difficult part. How do you see that?
So in research, indeed, we work very much with the proof of concept part. And I recognize what you're saying in the sense that we are historically physics-oriented company. So we have broken all sorts of boundaries in engineering systems that challenge what we thought would physically be possible. And a lot of that mindset of breaking the engineering limits is there. So that is part of our day-to-day challenge. And in the AI group, such as our group, we try to kind of invert the pyramid in the sense that traditionally people think about developing the hardware, then the software to control it, then the algorithms on top of that. We try to turn it around. We try to think first of what kind of algorithms can actually lead to the next generation improvements.
So thinking from AI to a machine.
Precisely. So inverting the way of thinking, like what if we start from the algorithm, what kind of information do we need, and then build the machine backwards from there. So we act here as the counterforce to the hardware, software, algorithms, data, AI kind of pyramid. And we then try to put AI at the basis of it, and then build the rest of the algorithms software in order to fit what we need. So we're the counterforce there. And when that approach is taken, then the deployment of AI becomes a given.
Exactly. But this is a totally change as a machine building company, right?
Correct. So I'm not saying that we will totally invert it, but we're the counterbalancing force in that.
Are you building all of this yourselves, or do you need help with university researchers, etc.?
No, so the answer is whether we're building it ourselves is absolutely not. So I think one of the key elements of the success of ASML is that we're of course very good in building it ourselves, but we're even better integrators. So core part of ASML is what we call the system engineering, where we are able to decompose a massive elephant into parts where we can rely on various partners, both suppliers, and then we're able to work very closely with them, clearly defining specifications, understanding how each one of the parts will influence another one. And we see also ourselves in the very same way when it comes to academic collaborations. We see ourselves as the integrators of the knowledge that the universities bring. And hopefully we can inspire them with the complex problems that we're facing. But definitely, it's not our ambition to do everything ourselves. We need to do it in close collaboration.
For sure, you work with Zeiss and Trumpf. We all know these projects in Germany. They are very proud of your cooperation between ASML, Trumpf, and Zeiss, and etc. But AI partners are maybe different or maybe more complex to handle. Or am I wrong?
They're certainly different, and historically, they're not as well established as all the hardware partners that we have. Like in our research domain, we establish core partnerships with universities, making the best use of their knowledge in the domains that we need, and then we integrate it towards building increasingly complex algorithms and systems.
Can you share some free AI research project you developed in the moment together with university research institutes?
Sure, I can give you like an example. I can give you a few examples. Like one of the examples is like, for example, what we're doing with the University of Eindhoven.
Oh, great! Yeah.
So that is the work of Tim Huben, PhD student in our group, where he is doing 3D depth estimation from a single SEM image. So traditionally, we would only get a 2D image, but from that, he is extracting the third dimension. This is like one of the examples where the algorithms can actually enable us to get the same results with simplified or with the same hardware. We could think of different approaches to make all sorts of measurements to use the existing algorithms to reconstruct the 3D image. But if we find out that the right information is there in the minimum amount of data, then we can keep the hardware as it is. We can also potentially simplify the hardware and actually extract more information out of that. That is one project that has been ongoing for several years.
But that sounds like a Gen AI approach from my point of view, right? Because you establish something, right? You generate something.
I would not call this one a Gen AI type of approach. It's a reconstruction kind of approach. Sure, we're generating ultimately three-dimensional image, but we are taking into account the known physics from the simulated data that we're using for the training, also mixing it with real data, and yes, ultimately generating three-dimensional image out of that we can use for metrology purposes.
Okay.
Another example, maybe more related to the Gen AI domain, so that is...
Oh, we don't need to talk about Gen AI. I was thinking about that, yeah.
Right.
Because I think Gen AI systems will go in this direction. Yeah,
definitely. Like, I think Gen AI will greatly help us in our diagnostics domain and also in helping us design new products.
Yeah, because I saw something from Anthropic. It's called Newton, a foundation model that learns the physics all around. So I think that's the direction where Gen AI is going. Yeah,
correct.
Yeah. So the second one, sorry.
Right. So like in the second one is where it falls in the category of knowledge and reasoning. And there we want to use that for diagnostics purposes. So we have, in order to make a reasoner, we need to be able to feed it with information. So we can store that information in something like a knowledge graph. And we can do that manually, but that is a very intense kind of process. So we want to also be able to automate that. And we would like to automate that by reusing the existing documentation. So that would be written text, that would be images, schematics that we have from previous system designs. Be able then to generate the logical relationships between them, feed that into the knowledge graph. Plus, the other aspect of the project relates also to extracting information from observations. And then using that knowledge graph to help us generate hypotheses when something is going wrong in the system, which for us in ASML, that is a very critical thing when something is going wrong.
So it's a root cause analysis, right, at the end?
Yes, you could call it a root cause analysis. However, in the diagnostics domain, it is, of course, important to find out the root cause, but more importantly than finding out exact root cause is determining what action do we need to take to fix the machine as quickly as possible.
So it sounds like also that you will integrate agents in this topic to fix then the problem, or am I wrong?
No, in this case, we're not taking an agents-based approach, no.
Okay. But do you think about agents?
Short answer, yes, but not in this context.
Okay. What about data? Is that a challenge for you to get the data? Do you work with scientific, artificial data, real-time, real-world data? So how difficult? Because from a lot of machine builders told us, oh, it's difficult, data. What is your opinion?
It needs to be approached very, very carefully. Like as ASML, we provide the core component in the manufacturing pipeline. But that also means that we do not own the full pipeline. Our customers do. And they differentiate themselves with the differences in the manufacturing process. Therefore, the data can be extremely secretive. So we need to approach it very carefully. And that also means that we do not have access to all the data that we would like to have. Having that said, that is also a motivator for us to use methods that bridge both the physics and the data approaches. Because if we were to approach everything from a data-driven perspective, the amount of data that we would need would simply be not attainable. So if we are able to inject more physics information, we're able to achieve the same results with less data. And that is also a big motivator for the research directions that we have.
What about federated learning? That could also be a possibility, right?
That could definitely be indeed a possibility that we would train the data at the different sites without any site actually having the full big picture. That the approach is definitely sound, but as everything when it comes to data, trust plays a big role. So if we go for such an approach, working on the trust of our customers and also making sure that there is no way that any information would leak and have ways to also transparently show and demonstrate that would be very important.
What about explainable AI? We had a discussion, I think, 3 weeks ago about explainable AI. The user wants to be informed when AI is taking over, making decisions. Is that a topic for your customer? Is it something you think about? Only a question of interest?
Absolutely, yes.
Yes? Okay.
And for our customers, they're also extremely technical. They do want to know all the details of the algorithms that we provide, the different models, and they are looking forward to the explainability of it. So-called black box approaches are very complex to justify, so we need then to put an extra layer of explainability.
That's difficult. Black box, gray box, white box, that's huge steps, right?
Correct. But from that perspective, one of the approaches that we're exploring is model discovery type of approaches, where from data observations, we try to, like as in any AI or in any machine learning model, find out the relationship between the data, and then when we have a new measurement, extract the parameters there. However, in model discovery, we do not try to find an interpolation between the previously observed measurements, but we actually try to find out the physical effects that are causing that observation. And from that perspective, model discovery can enable not only an interpolation between those data points, but actually an extrapolation. If we go to regions where we do not have observations, that potentially can provide us with a more accurate way to infer that.
You mentioned at the beginning physics and AI. We started with Hopfield networks. And do you think that physics and AI, bringing both worlds together, is the next big thing to overcome new frontiers with the help of AI for ASML, but also for other companies?
Certainly for ASML, I'm very confident that that will play a big role. So we're driven by the Moore's law. And as we're driven by the Moore's law, the physics become more and more complicated. So we cannot only rely on our understanding of physics. We also need to rely on the observations and the measurement systems that we have. So as the new frontiers, that research direction that we call them the knowledge-informed neural networks, that is definitely a frontier that, in my view, will also drive the next developments in ASML. And from that perspective, ASML is uniquely positioned there because we're really working at the edge of what is possible to achieve in terms of engineering for the edge of physics.
You mentioned edge. That's in a different perspective. Edge AI is also discussed in a lot of forums and newspapers, etc. What is your opinion on edge AI? Smaller, call it large language, smaller models on the edge. Is that a topic for you too?
Yes. So short answer, yes. So we need to be very careful how we optimize our computational pipelines. So as I mentioned, as we go for very high throughput type of systems, not only the processing time, but also the transmission times need to be taken into account. So we need to be able to very carefully balance what kind of processing do we do at each step of the pipeline, ensuring that the right information is flowing through, and keeping that as lean as possible. So from that perspective, definitely it's something that we need to be well aware of, and that will enable us to reach the high throughput processing that we require.
But in the end, not every machine will have a GPU, right? So that can't be the solution, I think.
Well, each machine will be part of a bigger processing pipeline. And there, very smartly, we need to be able to define what computational power to put where. Like the computational power right on the sensor, where the information needs to be immediately processed, the information that gets transmitted to the central computers of the machine, and the information that gets further processed on a local data center. And then we can even think beyond the information that is maybe processed in a non-local data center.
That's interesting. At the end, 2 more questions, please. When it comes to AI and your customer's shop floor, everything is very secret, you mentioned. How do you handle the ML ops topic then in the future and now? Because that's a crucial part when you sell something with AI, you need a ML ops pipeline.
Correct. And your question is, how do we handle the...
How do you handle, or do you have an idea how do you handle it in the future? Because you mentioned everything is secret, no data will leave the shop floor or will leave the machines. So how difficult is that topic discussing with your customer?
Well, that is a topic that we're maturing together with our customers. In research, we're a little bit further away from the MLOps part, but that does definitely play a key role when it comes to the deployment, to also being very transparent with our customers, how the pipeline is organized, how do we deploy our models, and also making sure that we're able to manage that per customer. We cannot afford to have leaks from one customer to the other.
Coming to an end, what is on your desk, Jacek? What do you have to get done in the next few weeks?
So what we need to do in the next weeks is driven by what we want to achieve in the long run. I think the strategic collaborations that we're working on with the universities, that is something that we're shaping. That is something that we're getting everybody to the common understanding first of the why, then the what, and then we can all work on the how.
That sounds like a manager, not like an engineer.
You're absolutely right. You're absolutely right.
From an engineering perspective, come back to your engineering history.
Okay, from an engineering history, what is currently on my mind? So I think topic-wise, as I mentioned, the physics-informed neural networks, the model discovery, those are on my mind. And now half manager, half engineer response. Also on my mind is also streamlining the way we do AI, making sure that we're able to build up on top of each other's achievements, to make sure that the way we organize our repositories, our code in the group and in ASML, that is all done in
That's a big topic, right? Yeah.
in a scalable way. Because if that is not something that we do, then we're only as good as the sum of the individual engineers. While we want to make sure that we actually create a multiplicative factor with the people that we have, rather than just an additive one. So I think that is on my mind, both from my software architect heart and current role as the group leader of the Diagnostics and Data Science group in ASML research.
That is very, very interesting, because 2 weeks ago we have some small events and we invite some people there and discuss topics. And there was a guy from Continental, German automotive supplier, and Bosch also. And they answered the same way. We have to organize our AI now, project management. Who is responsible? Do we have a clearing management system? Who is responsible at the customer side when it comes to AI? So all big companies, I think, have this huge, big topic on their desk, right?
Definitely. And I think that is also what determines the success.
But it's a good sign that AI is now playing a crucial part in this strategy, right? When you talk about project management, who's responsible, and it's not POC there and there, POC and there.
Correct. So indeed, and on a more practical engineering perspective, it's also making sure that people don't start every POC, as you said, from scratch, but that they're able to build on top of previous achievements. That is what determines indeed like our future success and how we scale AI here.
Jacek, it was a pleasure to talk to you about AI, ASML. We wish you all the best for you, ASML. Thanks a lot.
Robert, thank you. It was my pleasure. Thanks a lot for the invitation.